using Desmos on the Week 3 Honors Assignment. So I've added some directions in the worksheet to use Desmos. First, you're going to enter each side of the equation separately into a new line in Desmos. So I'm doing a new example. So you can see it at the bottom. I'm going to do 3 to the x equals 9 to the x minus 1, and then I'll also do 3 to the x is less than 9 to the x minus 1. So I've already entered the first equation. So instead of entering 3 to the x equals, I'm going to just do the left side first, so y equals 3 to the x, and then I'll do y equals 9 to the, when you do x minus 1 as an exponent, you have to put parentheses around it. Alright, so now I have both equations graphed over here, and I can see them both kind of well, but it's a little, I can see there's a point of intersection about right here. It's a little bit tricky to see what it is. You can change the scale, like I think my x-axis doesn't need to go all the way to 10, so I'm going to change that to like 6, just to get a little better. I didn't even need to go that far, but let's go to 5. And then I can make this screen bigger too, but I can see it's right around here is my point of intersection, which is good, but I can get a table from Desmos, which is even better. So go back to your first equation that you typed in, click on this Edit List button, and I'm going to duplicate that function first, and then I'm going to convert my duplicate to a table. So now I have a table of points that are on my first equation, y equals 3 to the x, that red line. And I'm going to do the same thing for the second one. So you click on it to enter into this line, then click on your edit list. First I'm going to duplicate the function so I can still see what the equation is, then I'm going to convert it to a table. Now I have tables for both of them, and I didn't even have to create the values on my own. And I'm looking for a place where they have the same values. So 0, 1, 1, 3, 2, 9, 0, no, 2, 9. 2, 9 is the same in both of them. So the answer to this question is that when x is equal to 2, y is the same value. So the answer for this would be when x equals 2. So for your solution, what you're going to add to your, let me hide this. What you'll add to the problem is you'll take a screenshot of all of this, or you can get a link, which is even easier, copy this, and paste it as your solution. And hit enter afterwards, then it makes it a live link that I can click on when I am grading your work. Now, there's an additional, you can leave all the same work for the second part of this, which is when is 3 to the x less than. You can leave all the same stuff, but we're going to add one more line in Desmos, and we're going to add exactly that. So we're going to say 3 to the x is less than, and it's 9 to the, and remember to use parentheses around the exponent, 9 to the x minus 1. So that now has shown up as this shaded area is the solution area. The point of intersection is the same. It's at 2. When x is equal to 2, they both share a point. And I want to know when is 3 to the x, which was my red line, when is that less than the green line? And the shaded region, I could have done it without entering this in. I could have just evaluated and said, well, look at that, it's less than it when. But this even reinforces what my answer would have been, which is that when x is greater than 2, like 3 or 4 or 5 or 6, the red line, which is 3 to the x, will be less than the green line. So that's what I would write for my answer. Here we go. So this would be, the answer for this one would be when x is greater than 2. So this one, did I write this answer? And then my graph, I could get another link to copy and to paste onto my worksheet so that I would also be sharing my work. Because you don't want to just put the answer without sharing how you got your work. So this is at x equals 2, and the other one was at x is greater than 2. So that's how you use Desmos to do this. It works really nice and helps you find all these solutions. And if you're looking at the other problems that you have to do, 1 and 2 are very similar to what I just did. Number 3 looks different perhaps, but the only difference is exponential, they're log. So let's just get a new, let's just delete all this stuff. So when you type this in, you'll be typing in this, again, you'll be doing the left side, so log of x squared, and then you'll be doing the right side. And in this one, I can't see where they intersect at this point, so I need to change my scale. Now just zooming out, which is what I'm doing now, makes it really hard to see anything, I think. So a better way would be to change the scale. I can see that my x-axis is fine, but my y-axis does not need to be so enormously big. So I'll go from like maybe negative -8, I guess, 2. I only need to go to like 2 because everything is happening like right here. Oh, I guess I had to go up to 6. Try that again. I'll go to 7, so I see a little bit above that line. And my x-axis, look at, there's not even a point of intersection at -100 to 100. They're not intersecting. So let's see what happens when you get your table. Maybe something will show up on the table. So I'll convert to tables. And I'll do the same thing for this one. This one, the table is going to be silly because you're not going to ever, there's no sense in even doing a table on this one, but I'll show you what happens. Everything is 6 because the equation was just y equals 6. Oh, I didn't duplicate it, but you can see that it's a silly little table. So we really need to find when this one is equal to 6. That's what we really need to find. So you can add values to your table. Let's add 6. And now we see, oh, we need when y is equal to 6. I don't know if I can add a value to the y side. No, I can't. So to find the point of intersection on a graph, we're just going to have to keep zooming out till we can find it. Let's see if we can find it yet. It's a really big number. There it is. 995 doesn't work. Let's see if 1,000 works. There it is. So my table did not automatically give me the values that I need to find the point of intersection, which is kind of a bummer. But by zooming out and changing the scale and by trial and error here a little bit, we were able to find when we had a point of intersection. All right, hope that helps. Let me know if you have any questions and have a great day.